Good day everyone, here's our math challenge for today. And here's our question. Our question for today comes from 1990 Indian Math Olympiad. The question is, given this equation, xy minus 7 quantity squared equals x squared plus y squared, then our goal is to solve for all possible values of x, y, wherein x and y are in the set of positive integers. Now, if you want to try this problem, just pause this video. We have 20 seconds and timer starts now. Time's up. Now, let's answer this question together. Now, first thing to take note is x and y must be both positive integers. So, if we get the value of x and y equals to 0, so this is not possible. And if we get negative values for x and y, this is also not possible. Now, the question is, how are we going to answer this question? Now, let's take first the given equation. We have xy minus 7 quantity squared equals x squared plus y squared. Now, let's focus on the expression on the left-hand side of our equation. Now, let's expand xy minus 7 quantity squared. If we do that, we get xy quantity squared minus 14xy plus 49. Now, at this point, let's focus on the right-hand side of this equation. Now, take note that this is almost a perfect square trinomial, because if we have a plus b quantity squared, this is equivalent to a squared plus 2ab plus b squared. The only missing term in this expression is just 2xy to make this a perfect square trinomial. So this is easy to do. Let's just add 2xy on both sides. Now, x squared plus 2xy plus y squared is now a perfect square trinomial, and this can be factored as x plus y quantity squared. Now, negative 14xy plus 2xy is just negative 12xy. Now, also notice that xy quantity squared minus 12xy, if we add 36 in this expression, this is also a perfect square trinomial. So, let's pull out 36 to this 49. So, let's split this 49 into 36 and 13. Now, take note that 36 plus 13 is just 49. And now, xy quantity squared minus 12xy plus 36 can be factored as xy minus 6 quantity squared. Now, at this point, let's subtract 13 on both sides. And let's subtract x plus y quantity squared on both sides. And the question is why we do that. Now, notice that we have a square number minus another square number. So, we can use the difference of two squares. If we have a squared minus b squared, it is equivalent to a plus b multiplied by a minus b. Therefore, the left-hand side of our equation can be factored as xy minus 6 plus x plus y multiplied by xy minus 6 minus x plus y. Now, let's simplify this expression. This can be written as xy minus x plus x plus y. On the other hand, the second expression can be written as xy minus 6 minus x minus y. Now, let's rearrange some terms a little bit. And now, notice that it is equivalent to negative 13. And 13 is a prime number. And also take note that x and y are both integers. Therefore, the only possible value of these factors must be this is 13. If this is 13, the other factor is negative 1. Also, if this factor, if negative 13, the other factor is positive 1. Another possibility is this factor is 1 and the other factor is negative 13, or this is negative 1 and the other factor is positive 13. Now, at this point, let's do this case first. So, xy plus x plus y minus 6 equals negative 1, and xy minus x minus y minus 6 must be equal to 13. Now notice that if we add these two equations, a lot of terms cancel out. This positive x and negative x cancel out, this positive y and negative y cancel out. Now if we add these two equations, we get 2xy minus 12 equals 12. Add 12 on both sides, this will give us 2xy equals 24. Divide 2 on both sides, this will give us xy equals 12. Now set aside this result for a while. Now what will happen if instead of adding, we subtract these two equations? Now notice that this xy cancel out and this negative 6 cancel out. So this will give us 2 times x plus y equals negative 1 minus 13 or just negative 14. Now divide both sides by 2. This will give us the value of x plus y must be negative 7. Now consider these two results. So we have x plus y equals negative 7 and xy must be 12. Since x and y are integers, the only possible value of x and y must be negative 3 and negative 4, or it can be negative 4, negative 3. So if x is negative 3, y is negative 4. If x is negative 4, y must be negative 3. But again, take note that we want x and y must be a positive integer. Therefore, this case is not possible. So what we're going to do is to do all cases until we get a positive integers x and y. So let's do that. Let's make a table and summarize our result. Now this table says that if the first equation equals negative 1 and the second equation equals to 13, then if we add these two equations, we get the value of x times y must be 12. And if we subtract these two equations, we get the value of x plus y must be negative 7. And also, using these two equations, we can solve the values for x and y. Now let's have now the second case. So what will happen if the first equation equals 1 and the second equation equals negative 13? Now if we add these two equations, we get the value of xy must be 0. And if we subtract these two equations, we get the value of x plus y must be equal to 7. Now we have an equation xy must be equal to 0 and x plus y must be 7. Now clearly, the only possible values of x and y must be if x is 0, y must be 7, and if x is equal to 7, then y must be 0. Now this case is not also possible because x and y must be a positive integer. Since 0 is not part of a positive integer, then this case is not possible. Now let's start with the third case. So what will happen if the first equation is 13 and the second equation must be negative 1? Now if we add these two equations, we get that the value of xy must be 12. And if we subtract these two equations, we get the value of x plus y must be 7. Now xy must be 12 and x plus y must be 7. Now clearly, the only possible values of x and y must be if x is 3, then y must be 4. And if x is 4, then y must be 3. Now let's start with the last case. If the first equation must be 13 and the second equation must be 1. Now if we add these two equations, we get the value of xy must be 0. And if we subtract these two equations, we get the value of x plus y must be negative 7. Now the only possible values for x and y wherein x and y are integers is when x is 0, y is negative 7, and when x is negative 7, y must be 0. Now on these four cases, the only case that will give us a positive integer x and y must be this case wherein the first equation must be 13 and the second equation must be negative 1. This will give us the value of x and y as 3, 4 and 4, 3. Therefore, given this equation xy minus 7 quantity squared equals x squared plus y squared, wherein x and y are both positive integers, the only possible pair of x and y must be 3, 4 or 4, 3. And as always, we are done.